All right, geometry. We're starting off in 8.1 now. So this chapter really goes over a lot of trigonometry, Pythagorean theorem, a lot of triangle relationships. So first thing, before we get to the trig, is something called the geometric mean. And the geometric mean is just the product of the square roots of two positive numbers. So if I ask you to find the geometric mean between the following sets of numbers, that just means I'm literally just going to multiply together their square roots. All right, so what I'm going to do is I'm going to take the square root of 6 times the square root of 54. Well, 6 times 54, that comes out to be, what, 324? So this is really the square root of 324, and the square root of 324 is 18. All right, so 18 would be your answer. Now, let's say, hypothetically, we didn't know that the square root of 324 is 18, which I don't expect a lot of you would know that. If you are in a situation like that, you can reduce this, right? I can try to break apart this 324, and the first thing I see is that it's divisible by 2. Yes, that's true. It is divisible by 2. It's divisible by 3, which is great. It's divisible by, 4. It's divisible by a lot of different things. So I would try to look for a perfect square that goes into 324. So what rings a bell in my head is 9, because if I add up the digits, 3 plus 2 is 5, plus 4 is 9. So because the 3 digits add up to 9, I know that this number is divisible by 9. So I'm going to take 324 divided by 9. Well, 9 goes into 32 3 times. Minus 27 is 5. Bring down the 4. 9 times 6 is 54. So square root of 324 is really the same thing as the square root of 9 times the square root of 36. Well, that's pretty easy here because I know the square root of 9 is 3, and I know the square root of 36 is just 6. And would you look at that, 3 times 6 is 18. So we get 18 either way. All right, I know some of you do a method where I think you do a prime factorization tree maybe, where you take the 324 and you break it down into 2 times 162, and you break that down into 2 times 81, and then that's 9 times 9, and then you got the 3's, and then you circle your pairs. There's a pair of 2's. So you can do it that way too. That would give you 9 times 2, which is 18 anyway. So that would also work. There's many different ways to do this. But again, the more perfect squares you know, the easier your life's going to be. So next one. I'm going to take the square root of 10 times the square root of 15. So this is the square root of 150. So again, I'm going to try to break this down into 2 perfect square factors because 150 itself is not a perfect square. So 15 times 10, well, those aren't perfect squares. 5 times, that's not going to work. So you're trying to think of a perfect square. I would say 25 is going to be our best option. So I'm going to break this down into 25 times 6. Well, I know the square root of 25 is 5, and I cannot take the square root of 6, so we are done. That's our simplified answer. So geometric means, sometimes it might be a nice number, sometimes it might have a radical in your final answer, but that's okay. Similarity within right triangles with altitude. So there's a special relationship that occurs whenever you have a right triangle. Notice how ABC is a right triangle here. And when you take this right triangle and you draw an altitude from the right angle, so it doesn't occur on the other angles because they would just be the sides. It has to be from the right angle. I have a situation, all right? And the situation is that all 3 of these triangles, triangle the small one, triangle the medium one, and triangle the big one, are all going to be similar to each other, all right? So what I would do to kind of match these up appropriately is redraw these all oriented in the same way. So I'm actually going to take triangle ACD and orient it in the same way it's oriented there. So my right angle, there's ADC. And now I'm going to try to take this triangle and orient it in the same way. So I'm basically going to kind of take it and then rotate it upwards. So that's going to give me, this is a little bit bigger, so I'm going to draw it a little bit bigger as well. It's kind of like our medium triangle. We got the right angle at letter D. B rotated up, so B is going to be the high point up here. And then C would be down there. And then I've got this large triangle here. So basically what I'm doing is I'm going to, mirror image it, and then I'm also going to rotate it, if you can visualize that. And basically that's going to be the biggest triangle of them all. We got our right angle down here at letter C, right? This letter C is the right angle of the large triangle. Letter A and letter B. All right. So these triangles are all similar to each other. All right. These always work out to be similar. So very interesting relationship we have. So if I look at, I can always label the sides, right? AD, so this is X. DB is Y. BA is C. So you can go ahead if you wanted to label all these. This is H, CA is B, BC is A, and then AC is B. So you can label all these if you wanted to with the different values, so you can kind of compare the sides, which you'll have to do eventually when we get to these next problems here. But you're going to be asked to write a similarity statement for the three triangles above. So we're going to say that triangle, and again, you can pick whatever order for the first one, but once you pick an order, you got to stick with it for the remaining two. So our similarity statement is going to involve three triangles. I'm going to say triangle DCA. So D to C to A, that's going to match up with DBC, which is similar to triangle CBA. And that's about it. So from this information, you can make really any proportion you want, right? I could look at H and B. Oops. And so I could say that H over B equals, well, then I can look at, I don't know, let's say Y and A, right? Y over A. So you can compare any of those corresponding sides in any of the triangles. This is also going to equal X over H. All these are equal, right? Because notice I'm comparing the bottom sides, X, H, and B. There's my X, H, and B. Sorry. I'm comparing all those together, and then I can... I'm sorry. I take back what I just said. Sorry. Don't ignore that for a second. Don't look at that. This would be a good proportion that we can make. This still stands. This is true. The one that I made, I'd have to go back and I'd have to rewrite this. Sorry about that. Okay, so this is true. You can keep that there. That's true. But what I'm looking at here, what I was focused on, is if I look at all three of these sides, I could compare X over H, which is this comparison. That would equal H over Y, which is this comparison. And that would equal B over A, which is that comparison. So this would work. This would be true. And you could pick any of these two, and that would work out for you where you solve that proportion. But if you were to compare H over B, which we do here, that would have to equal Y over A, which we have here. All right. So again, with the proportions, you can really pick any two that you want and then just run with it. All right. All right. So moving on. Let me erase that right there. Okay. So on the next page, we're really just kind of trying to write these similarity statements and then find the missing segments. If you're getting these wrong and you're not understanding this, and you're not redrawing it, that's where the issue is. So if you have questions on this or need help or anything like that, but if you don't have it redrawn, I'm most likely not going to help you, because the first thing I'm going to say is to draw the picture. And once you draw the picture, you're probably going to know exactly what to do. So just something to think about. When I reorient these, I'm going to take my smallest triangle here. Smallest triangle is DBC. Medium triangle, that's not what I want, sorry. Okay, the medium triangle, when I orient this, the right angle is angle D, right? There's my right angle. CA and A. And then if I look at the largest triangle, we've got angle C is the right angle, B and A. All right. If you're having trouble orienting these, again, I would just go ahead and look at what angles have to be matching up in these corresponding shapes, right? Start with your right angles. The right angles are always marked for you. And then look at your other two angles. You'll notice that one angle is going to be larger than the other, or you can think about, one side is shorter than the other. And so in this scenario, that should allow you to match up the short sides and the medium sides and the long sides, or same thing with the angles. So if I look at these shapes, and now I'm going to label AD. Anytime I see AD, I'm going to label it as 8 inches. So AD, 8 inches there, and I think that's about all we got. And then I'm going to look at DB, which is 2 inches. So DB is 2 there, and I think that's all we got. Now we want to find AC, CD, and BC. Now if they tell me that AD is 8 inches and DB is 2 inches, I actually know some other information, right? I actually know that this whole distance, AB, is 10, right? So this whole thing is 10 inches, right? 8 inches and 2 inches. All right. So from here, I'm actually going to have enough information, because if I'm trying to find, let's say, let's try to find CD. All right, if I'm trying to find CD, I'm going to put the letter X here. So I'm going to put the letter X for CD. And notice CD is also here as an X. Okay. Then I'm going to label AC. I'm going to label AC Y. How about? So I'm going to call it AC Y. So if AC is Y, notice I can put the letter Y here, but I can also put the letter Y in this triangle. And if I'm looking for BC, I'm going to use the letter Z. And BC is a letter Z in this triangle, and it's a Z in that triangle as well. So even though it looks like originally we just don't have enough information, we actually do have plenty of information. So what I can do is I can look at, let's say, my two smaller triangles, all right? So I'm going to compare, I definitely want to include the 2 and the 8, right? Those are the numbers that I have to work with. So I definitely want to include the numbers, and I want to pair them up with the corresponding sides. Well, notice, I'm going to use different colors. Notice that the 8 corresponds to the X, so I can write 8 over X. And also notice, trying to get my colors figured out here, that the X on this side corresponds to the 2. So I can write X over 2. Now, even though we have technically two unknowns, right? We don't know this numerator and that denominator. Luckily for us, it's the same variable. So when I cross multiply, we find out that x squared equals 16. While when I take the square root of both sides, we find out that x is 4. All right. So that means since x was the value of CD, right? CD is x right here. I know that CD equals 4. All right. So that's very nice. And now I can kind of keep finding my y's and my x's. So if I look, let's say I'm trying to find, let's try to find CA next. Let's try to find y. So when I look, use some different colors here. I look at these two triangles because these two triangles both have the letter y in them. So when I look at this, I'm going to look at y over 8 because y and 8 are corresponding sides. So I'm going to compare the y to the 8. And then I'm going to go ahead, let's use blue, how about? I want to compare this y to something. Well, that y matches up with the 10. Now I do have to compare the same thing in the same order. So this has to equal 10 over y. I can't do y over 10 because again, when I compare things, I have to compare in the same order. So y over 8 is 10 over y. All right, when I cross multiply, we get y squared equals 80. I can take the square root of both sides. Square root of 80 is not a perfect square, but I can break it down into 16 times 5, and the square root of 16 is 4. So I know that AC is 4 square root 5. All right, and don't forget to put units on all these. And then the last one, I'm looking for Z. All right, so I'm going to use, let's do pink here, I guess. So if I'm looking for z, I want to use this triangle and this triangle. All right, so I'm going to compare z over 2. So z over 2 is one of my fractions. And then let's use orange. I'm going to compare this z, that's a hypotenuse, to this 10, right? Those are both my hypotenuse. Now again, I can't do z over 10, I have to do 10 over z. The reason why I have to do 10 over z is because I have to compare the same thing in the same order, right? Z over 2 is 10 over z. All right, so those are equal to each other. Cross multiply, z squared equals 20. We're going to go ahead and take the square root of both sides. So we end up with z equals square root of, I can break this down, right? That's just 4 times 5. So z equals 2. Sorry, I'm not going to use z. I'm going to use, what was this, side CB, right? So CB was my last side. That's 2 square root 5. And again, don't forget to write the word units there. All right, so those are my missing sides. And you guys know the Pythagorean theorem already, which we're going to learn it again, but you already know how to do it. So you could use the Pythagorean theorem here to verify all your answers, right? If I'm looking at, let's say I'm looking at triangle CAD right here. If I'm looking at this triangle, that means that I've got the bottom side is 8 inches. We said that CD was 4 inches. And then we said that CA was 4 square root 5 inches. Also, I believe I said units, but we know this is inches, right? So make sure it's in inches, not units. I think I misspoke on that. So we can verify this, right? We know that 8 squared plus 4 squared has to equal 4 square root 5 squared with Pythagorean theorem. We can verify 64 plus 16 equals, well, 4 squared is 16, square root 5 squared is 5, 80 equals 80. Check, that is true. So again, the thing I love about these is that you can always double check your answer. If you plug it back in using Pythagorean theorem, you can verify that you did do these problems correctly.